a fisherman that's hanging a fish from an ideal spring that has a negligible mass.
Okay.
Like my fish.
Yeah, it'll work.
It's got 65 kilograms and stretches the spring. So let's say this was the natural length. So it stretches the spring 1.2 meters, or 0.12 meters. And we want the force constant of the spring. The fish is now pulled down 5 centimeters and released. What is the period of oscillation? So if you take the fish and you pull it down an additional 5 centimeters and release it, it'll start oscillating up and down. Okay, and I want to know what is the period of that oscillation and what is the maximum speed fish. Okay.
All right.
So, any ideas? Where do we begin?
Well, the only force acting on the spring is the weight of the fish, so we need to calculate the weight of the fish.
Okay.
65 times 9.8, 637. And 637,
What does Hooke's law state?
that the restoring force is going to try and...
Distance y. Now, the problem itself, though, in this case, I believe it would be positive.
Is it because the restoring force is going in the positive direction?
Uh-huh.
What we need to do here is, since we have the force 637, and we know how much of a distance that force created.
Whenever we put the fish on the spring, it went down 0.12 meters.
It went down initially 0.12 meters.
Yeah, so that would be the distance traveled. Divide both sides by the 0.12.
Yes. We should get a number like 5,308.
How many sig figs was that's going to be?
It should be 2.
2. So
5.5300. Yeah, that'll work.
all right. So now let's do part B.
Okay.
The newtons for the symbols for this is Newton meters.
Newton meters.
So part B says that we pull it, right? And when we pull it 5 centimeters, it starts an oscillation. Okay, and we want to know what the period is.
So it's in total. So the distance is 0.17 meters.
No.
No.
Uh-huh.
That's not the total length.
No. It's not going to be the resting. You got to think about it as this: the point that the fish naturally wants to rest is right here at that 0.12. So if I pull it down a little bit, then it's going to bob up and down on either side of that 0.12 meters away from whatever it's attached to.
Okay.
Okay. So the amplitude itself would be the 5 centimeters. Okay.
All right.
For the period, do we need the amplitude? What is the formula for period?
Period. The formula is square root of m over k, 2 pi square root of m over k.
Okay. So then we know that the mass is 65 kilograms.
65 kilograms.
We just calculate K to be 5,300 Newton meters, sorry. And then at that point, when we do all that, we should end up with 0.0695 seconds. You with me?
Mm-hmm.
Right.
And now we can find its max velocity. because we have the speed, we have we have the time.
Okay, what is max velocity equal? We know that the amplitude was the 5 centimeters, but what do we have to do to that 5 centimeters?
We have to put it in terms of meters, right?
Okay, so, correct. So if I have 5 centimeters, I put the units that I have on the bottom, the units that I want on top, and then put a 1 for the larger one. How many centimeters in a meter?
100.
100. If you do it the way I just did it, by putting a 1 on the larger unit, you never have to worry about the negative exponents. Some people have issues with that. I doubt you do, though, if you're a smart young man.
2 pi times 0.05 meters divided by the 0.695.
And when you do that, you should get, what, 4... Okay.
Which just comes out to be 0.45 meters per second by sig figs.
Good. Actually, by sig figs, it would be 0.5 meters per second because that only has 1 sig fig.
Oh.
Sig fig to the left of the first non-zero, or zeros to the left of the first non-zero number aren't sig figs.
Right.
Okay. So, but that's basically it. Do you understand how we did that?
I understand how we did that. We used the equations,
Yeah.
and we just plug and chug.
Yeah. Period. You got to know Hooke's. This is Hooke's law. All right.
Okay.
And the restoring force was positive. That's why this is not negative. Usually that guy's negative. We used that to calculate the spring constant. Then once we knew that, we could calculate the period because we needed the spring constant right there. And then once we knew the period, we could calculate Vmax.
All right.